Welcome, ladies and gentlemen, to sqadia.com. My name is Muhammad Osama, and today we are talking about data collection in medical research and statistics. And this specific topic is about psychometrics, validity, and reliability for setting a new questionnaire. So we are going to talk about designing a new measurement tool, its validity, and its reliability. So let's start off with designing a new measurement tool and psychometrics. So sometimes researchers need to develop a new measurement or questionnaire scale because when we conduct a research, we need an outcome measurement tool. Sometimes we have an outcome measurement tool for that, and sometimes we need to modify it. But sometimes that what we are looking for, we do not have an outcome measurement tool for it, and we need to make a new outcome measurement tool designed for that specific purpose. And then we need to design a new measurement tool, and we need to know how to do it. And that is also a type of a research to develop a new measurement tool. So to do this rigorously requires a very thorough process. First of all, the following properties of measurement scales are important when we are designing a new instrument tool. Those include face and content validity and empirical validity, as well reliability and stability of that questionnaire outcome measurement tool, and internal consistency of that measurement tool. So let's start off with face and content validity. So face validity is a question. The question is the scale measuring what it sets out to measure? Now the thing is that this is subjective, and it is achieved by consensus among experts. So face validity is a subjective property of an outcome measurement tool. Then there is the content validity. Does the scale cover all the relevant areas of what it is intended to measure? So this is also subjective and is achieved by consensus among experts. But there are other types of validity which are known as empirical validity, which means when the scale measures the trait, behavior, or symptom that it is set out to measure, and we can actually objectively find out if it is there. So there is convergent criterion and concurrent validity and construct validity. So when I talk about convergent criterion or concurrent validity, so it is for those outcome measurement tools for which we have similar outcome measurement tools who assess the same thing already present. So we have pre-existing tools like that. So it is tested by comparing it with another similar scale to see if both give a similar result. For example, in developing a shortened version of an existing but longer questionnaire, for example, there's physical activity questionnaire and someone is designing a smaller part or a smaller version of it, like a short international physical activity questionnaire. So for that, you would use convergent criterion or concurrent validity, and that needs to be established. The other is construct validity. It happens when there is no similar scale to compare it with. It is something new. You don't have any existing outcome measurement tool to measure that specific variable. So in that sense, researchers apply a series of tests where the answer is known to check that scale is behaving as expected. For example, if the person's intensity of symptoms increase, then the score on that outcome should increase as well. And when that person is given treatment and his symptoms tend to improve, then the score on that outcome measurement tool should also improve. So those are the things that actually show that this specific type of measurement tool has construct validity. Now moving on to reliability and stability of outcomes. So questions like, are the measurements reproducible? Like if I measure this specific thing again, would I get the same result? And if you repeat the measurement, will we get the same answer? So questions like this tells us about the reliability and stability of an outcome measurement tool. There are three different types of reliability: between observers consistency, within observers consistency, and test-retest consistency. So between observers consistency is there an agreement between different observers assessing the same individual? For example, there's a patient, and one researcher takes data from him and he gets a result, and then another researcher takes data from him and he gets his result, and if they compare their results and their results are pretty much the same, so it means that there is between observer consistency. Within observer consistency, that if same individual is assessed by same observer on two different occasions and the results are same, so it means that there is an within observer consistency. And lastly, test retest consistency. It is also pretty much similar to within observer consistency, and in this, assessments are made on two separate occasions on the same individual, and if they are similar, then it means that there is test retest consistency. Now, there is another type of consistency which is known as internal consistency, and that happens when a questionnaire has more than one component. So if a scale has several items addressing the same issue, then we usually expect each individual to get similar scores for those questions. And if that person gets similar scores for all those questions, then it means that this questionnaire or this outcome measurement tool is internally consistent. So for that, a statistical quantity which is known as convex alpha is used to assess the degree of internal consistency. How is it calculated? It is calculated by calculating an average of all the correlations among different questions in the scale. So if there are 4 questions, we calculate the correlation of each question with each other, and then we take an average of it and we get the convex alpha. So the value of the convex alpha, just like simple correlation, lies between 0 and 1. So 0 means no correlation, 1 means maximum correlation. So values are expected to be above 0. And below 0.9 to show that there is maximum consistency, maximum internal consistency and correlation. Below 0.7 means that the internal consistency for this outcome measurement tool is weak, and above 0.9 suggests that the items are very similar and perhaps fewer items could be used to obtain the same overall information. So high internal consistency is not always expected for some questionnaires, because some questionnaires contain different health questions which might not necessarily be answered in a similar way by the same individuals. So it is possible that for some questionnaires, Cronbach alpha does not apply. So here, this chart can actually give you a good review or summary of the values of the Cronbach alpha and how it relates to internal consistency. So above 0.7 is actually an acceptable value for an internal consistency of any outcome measurement tool. So it should be above 0.7. So if it is between 0.8 and 0.7, it is acceptable. If it is between 0.8 and 0.9, it's good. And if it's greater than 0.9, it's excellent internal consistency. And if it's between 0.6 and 0.7, it's questionable. If it's between 0.5 and 0.6, it's poor. And if it's less than 0.5, it's unacceptable. But usually it should be above 0.7 for if you want to use that outcome in your research. Now, measuring reliability when the data is continuous, how can we do that? So repeatability both within individuals and between observers can be quantified in several different ways. So in many medical studies, the actual size of the differences between repeated measurements is of interest, and so the bland Altman limits of agreement gives us a summary of this. So we can use bland Altman limits of agreement for if you want to look at the actual size of the difference. Another thing is based on the coefficient of variation, which depends on the standard deviation of differences divided by the mean. So if a relative summary is of interest, then we can use the coefficient of variation, which can be helpful, and especially if standard deviation is proportional to the mean. So we can use the coefficient of variation to also measure the reliability for continuous data. Third, which is perhaps the most easiest, is to find out the intra-class correlation coefficient, which is also used sometimes, and it is the easiest perhaps. And this is a dimensionless quantity that can be used to compare the repeatability of several measures. Measuring reliability, categorical data. If you are using categorical data, then to assess the level of agreement for data that fall into categories, then Cohen's kappa is used. So that was all about collecting data and different topics that we discussed into it. I hope it was beneficial for you and you learned something new out of it. And keep on watching sqadia.com for more lectures like this. This is Muhammad Osama signing off. Thank you very much.